So we're looking at Algebra 2, Section 1.5. We are solving inequalities. We are going to do them a little different than the way your textbook does them. So when you're doing your homework tonight and you're trying to check your answers in the back, keep in mind that the notation you're going to see there isn't going to match what we're going to do in class. Okay? The notation that you see in your book is the way you learned it in middle school. We are going to prepare you for other classes that you're going to take in the future that use a different notation. Okay? So we are solving and graphing algebraic inequalities. We are going to write and solve compound inequalities. Starting out, just refreshing our memory. How would we read the first statement there? Good. X is less than 2. Now, in the past, in the old days, the good old days, when you graphed that, you would have made a number line. And some teachers make you put a whole bunch of numbers on your number line. I just require that you put the key number, in this case the 2. Okay? So we have to label a 2 in there somewhere. And we want x's to be less than that. So what notation did we do in the past? Okay, so open circle, right, at the 2. And that open circle indicated that we are getting close to that, but not quite there, right? And then it says we want to be less than that, so we need to shade to the left, okay? So we typically would just draw an arrow to show we want all the numbers beyond that on the left side. Yes? Okay, we are going to change that up in a second, but we're going to do this next one first. How do I read this next one? So x is greater than or equal to 5? X is greater than or equal to 5. So on a number line, we would have said, all right, we're going to put a 5 in here. If we can be equal to it, what do we have to put in there? Closed circle. Good. So we do a closed circle and shade which way? Okay, shade to the right. So again, that's the old notation. All right? What we are going to do is called interval notation. And with interval notation, we are going to identify some interval on our number line that represents the numbers we want. Okay? The numbers that are less than 2, the numbers that are greater than or equal to 5. So picture on a number line, we would start with 0 here in the middle, we'd have 1, 2, right? And we'd keep going. What's at the very, very end of that number line? What's at the very, very end? I didn't hear you. Is 100 the end? Is 1,000,000 the end? 10 million? 53 billion? What's at the very end? Infinity, right? It keeps going. Positive infinity is over here on the very end of that number line. We can keep going and going and going forever. We're trying to get there. Yes? Do we ever actually get to infinity? No. What would be on the far left of our number line? Negative infinity. Good. So when we talk about numbers like this first one where we said x has to be less than 2, we're really saying it can be anywhere from this almost to the 2 mark and all of this stuff all the way down to negative infinity. Right? So I want to indicate that interval of my number line, the chunk that I want, all of those numbers. So I would say I'm going to start over here at negative infinity and I'm going to go all the way up to the 2. Okay? For the next one, I'm going to come back to this in a minute. We're not quite done there. Okay? I just want to compare them. For our next one, for x being greater than or equal to 5, we're saying we're going to start at a 5 and go all the way to positive infinity. Does that make sense? That's the interval that I want. Now, notice we always go from the smallest number on the left to the bigger number on the right. So I'm going from negative infinity to the 2, but on the other one, I don't say infinity to 5, right? I start with the smallest number, the 5, going up to the biggest number, the infinity. Okay? We said earlier we can never get to infinity or negative infinity. So the symbol we use for that is a rounded bracket wherever you see an infinity symbol. Okay? That's going to have a rounded bracket. If we can't get to the number, it's rounded. If we can actually be at that number, we do a square bracket. So for this first one said we could get almost to the 2, but not quite there. We're going to have a rounded bracket on that. But for that 5, we said we could actually be at 5. So we're going to do a square bracket. Okay? So when we talk about interval notation, we're writing it inside either rounded or squared off brackets, and the numbers inside tell me what's the smallest and biggest number I can have. Okay? Sometimes it looks like an ordered pair. Like if I said I want to go from 2 to 5, I want the numbers from 2 here up to 5, but not quite including them. When I write that interval, it would look like that. Don't confuse that with being an ordered pair, a point on a coordinate plane, all right, even though it looks like it's the same notation, because you're giving me an interval. So we would recognize that as an interval versus an ordered pair. Now, for the graphs, the nice thing about interval notation is your graphs have the same symbols. So if I can equal it, if I can be at that value, I'm going to use a square bracket. If I can only get close to it, I'm going to use a rounded one. So my graph for this first one instead would be a rounded bracket at 2 with an arrow to the right. But for the 5, since I can be at 5, I'd have a squared off bracket and my arrow. Okay? So your squared bracket or your rounded bracket curve around, in the direction your arrow's going. All right, let's try a couple now with just doing the new notation. How do we read this next one? Good. X is greater than 3. So on a number line, we would need a 3, right? What kind of bracket would we use? A parenthesis, a rounded one? Okay. And are we going to the right from there or to the left? To the right. So we're going to curve it around towards the right and put an arrow. Okay? And what's way over here on the far right? Infinity. So we want the numbers between 3 and infinity. So we're going to notate that like that. The numbers between 3 and infinity without quite getting to either of those endpoints. Okay. Next one. We would read this as x is good, less than or equal to -1. Okay, picture your number line. You need a -1 somewhere on there. We want numbers that are less than or equal to it. So what type of bracket? Squared, good. Squared off bracket, and we're putting our arrow to the left. So our squared off bracket curves around that. Okay. For our interval notation, we are starting at what value? What's way over here? So we're starting at negative infinity. We're going up to -1. We can actually be at -1, so squared off. We can't actually get to negative infinity, so rounded. Okay? You guys are going to be experts at this next year and impress all of your pre-calc teachers that you already know this. All right, so our last one here we would read as, so we could write it 4 is greater than or equal to x, or we could start with the x and say x is, yeah. All right, so we've got our number line. We need a 4 on there. We're going to do what kind of bracket? Square pointing which way? Left. So we're starting down here at negative infinity and we're going all the way up to the 4. We okay with that notation? Okay. So that's the end of the new stuff today. Everything else we're doing you've worked on in Algebra 1. All right. So first question here says, write an inequality to represent each sentence. We're not solving anything. We're just trying to rewrite it instead of words. We're trying to put it in symbols. The product of a number of 7 and a number is no more than 50. What does product mean? Multiplication. So we're multiplying 7 and some number. What do you want to use for the variable? Okay. So we're saying 7 times x. And then what is no more than? Less than or equal to. It can get to it, it just can't go over it, right? So we want to be less than or equal to 50. Think of the word is as your equal sign. Okay, it's kind of breaking your sentence into the two parts. Okay, so this is on one side, and this is where our break happens. Does that make sense? Okay, next one. 5 fewer than a number is at least 12. What does it mean to be 5 fewer than? We're taking 5 away, right? If I said you have 5 fewer dollars from me, you'd have to take my total minus 5. Okay, so we have some number. We're taking 5 away from it, making it 5 fewer. And we want to have at least 12. Yes, greater than or equal to 12. Okay? Quotient means what? Quotient means division, yep. So the quotient of a number and 3, we're taking some number and dividing it by 3. That quotient is more than 15. Is more than means what? Greater than 15. Okay? Now, we're going to start solving some inequalities. We solve them with the same steps that we do for equations, all right, what we've been working on. But keep in mind, when you are solving, if you multiply or divide by a negative number, in the process of solving that inequality, the inequality symbol reverses, switches. So if it was less than, it turns into greater than. Okay? All right, so let's solve and graph some of these. What do you think we should do in this first one? There's a couple options. I heard distribute. Some people would look at that and say, I'm going to distribute that 4, get rid of the parentheses, clean that up. What's another option? I could divide the 4 over because the whole chunk here, everything in parentheses, everything on this side is being multiplied by 4, so I could divide it over. With a show of hands, how many would be distributing? Like when they first looked at it, that's what came to mind, distributing. Okay, we'll do it that way. Distributing the 4, we get 4x minus 28 is greater than negative 20. Then what? Add the 28, so 4x is greater than 8. And then we divide. Are we dividing by a negative number? No. So dividing the 4 over, we've got x is greater than 2. On our graph, 2 is our key number. We want values of 2 that are bigger than 2. So what kind of bracket? Rounded going right. So my interval answer is that I'm starting at almost 2 and I'm going all the way up to positive infinity. Okay? All right. Next one. We can go ahead and distribute that negative 2. We end up with negative 2x minus 18 plus 5 is greater than or equal to 3. Combining some like terms. Negative 18 plus 5 is, okay? Somebody else, what would our next step be? Add the 13 over and it gets us 16. Dividing out the negative 2. Now because we're dividing by a negative, we have to switch that inequality. So x is going to actually be less than or equal to 8. Sorry, negative 8. All right, so we need a negative 8 on our number line. And we want to be less than or equal to it. So what kind of bracket? Square. And going to the left. Okay? All right, I'm going to pause the recording for a minute. I want you to try the next one. I'm going to go ahead and work on it up here, and then we'll check our work. Okay? All right, how did you do? Did we get it? Do you need me to go through this one, or should we move on? Move on? Okay. So we are going to set up an inequality for this word problem. Yesterday we talked about setting up equations for word problems. All right, same idea for this. It says plumber A charges $75 for a service charge and $40 per hour for labor. Plumber B charges $50 per hour for labor but no service charge. How many hours must a plumbing job last for plumber B to cost less than plumber A? Okay, lots of information in there. This is a pretty common type of question, right? You've got two options of companies you can go with, two different subscription plans. What's the better deal? Okay. What do you think would be the better deal if I have a job that's only going to take 1 hour? Plumber B? Okay. Plumber B charges a little more per hour, but there's no service charge. Do you guys know what we mean by a service charge? It's basically they're charging you just to come to your house. They haven't done anything yet. They just showed up. Okay? You're taking up their time, their gas, all that. So they're going to make a charge, and then the rest of it will be based on how long they spend there. Okay. So plumber B charges $50 for every hour, but there's no extra service fee. Plumber A charges a service fee of $75, but then only $40 per hour. The question's asking, when is plumber B's charge less than plumber A? Okay, so we need to come up with expressions for each of these different plumbers. We said plumber B charges $50 every hour, and the question is how many hours should they work, right? So if we let X equal the number of hours, then plumber B would be 50 times X. Okay. What about plumber A? What's their fee? Is the 75 based on how long they are there? So it's just a plain 75, right? Plus 40X. Great. Can we solve that inequality? Okay. So first step, subtract the 40, which gets me 10X. And then if I divide out the 10, I end up with 7.5. So what this means is that any plumbing jobs that are going to require less than 7.5 hours, plumber B is a better bet. Once I go over that 7.5, at exactly 7.5, they're equal, right? Anything over that, if the job's going to take more than 7.5 hours, plumber A is better. Yes, there's a service fee, but I make up for it by the reduced rate per hour if they're going to be there for a lot of hours. Okay? All right, so to answer the question, it needs to be less than 7.5 hours. Okay, a movie rental company offers 2 subscription plans. You can pay $36 a month and rent as many movies as you desire, or you can pay $15 a month and then pay $1.50 to rent each movie. How many movies must you rent in a month for the first plan to cost less than the second one? So our unknown is how many movies? So we're going to let that be X. Okay. We want the first plan to be less than the second plan. All right, how do we represent the first plan? Is it $36 for every movie? Just a plain $36, right? Doesn't matter how many movies I buy. $36. The second plan, what do I pay? So $15, just a flat fee. Every month I'm going to pay $15. And then I only have to pay $1.50 for each movie. Okay? All right. So solving this, if we subtract 15, what happens? What's 21 divided by 1.5? So if I'm going to have X being greater than 14, right, so more than 14 movies, I'm going to go with plan 1, the first plan. Okay, if I'm going to get more than 14 movies in a month, which is a lot, right? It's one every other day. Then I pay the $36 and I don't have to pay for all the movies. Okay? All right. The last little piece, we're going to try to squeeze this in here. Do you remember when we talked about no solution or many solutions? It works with inequalities as well. Sometimes inequalities have no solutions, or all real numbers can be solutions, just like equations. I don't know why that was there. If I started to solve this first one here, I'd combine like terms. So I'd have 4 minus x is less than negative x plus 4. I'd then try to add an x to both sides, which is going to cancel my x's out. And I have 4 is less than 4. Is 4 less than 4? No. This is a false statement. If there had been an equal sign, so it was less than or equal to, then it would be true, right? Because it fits the equal part. It can be less than or equal, then it would work. But because there's no equal sign, I have to say no solution on that. Okay? For this one, if I distribute I have 8x plus 8 is greater than 8x minus 12. The 8x's would disappear. I'm left with x greater than negative 12. Is x greater than negative 12? 8, sorry, not x. Is 8 greater than negative 12? Yes. So this is a true statement. We'd say there's infinitely many solutions. All real numbers are going to work in that. Okay? All right. So what I'm going to have you guys do, we didn't get to the compound ones. We'll pick that up tomorrow. So go ahead and do this. All right, you've already done the 1,4b part. Do the 1.5a, and I'm going to put a question mark by that. If you want to look at that and maybe get a jump start on it, you can. But we'll try to finish up the 1.5b tomorrow. Okay?